everyone, and welcome back to Research Recap, brought to you by Arbor Assays. This is part 2 of our episode on giant panda research with Kirsten and her colleagues in Edinburgh. In this second study, the team built on their findings from their earlier work. If you haven't seen part 1 yet, we recommend going back to catch up. So let's get started. Can you tell us a little bit, as you were getting going in these studies, you mentioned some of the hormones that have, are there in pandas and not in others and vice versa. So can you walk us through the biomarkers that you chose to focus on and the ones that you were really diving into in this study and why you chose some over others?
Our second study looking at the breeding season for looking at ovulation, it was focused on androgens. So again, it's not a new marker. They're typically regarded as a male hormone, but based on the steroidogenic pathways, everyone has them because androgens are the precursor to estrogens. And because we were hoping to find something that might give us an indication that changes in estrogens were going to happen, we thought that, well, let's look at the pathways as a whole, what comes before. And so for us, androgens felt like the right step. So yeah, even though it's not something new at all, it's just looking at it in a bit of a different way. I mean, no one had studied androgens in female giant pandas before.
Yeah, but perhaps provides some new insights and things that you can unlock. So as you move into the new, you have kind of the markers that you're interested in. Tell us a little bit about your experimental setup, how you actually got the experiments designed, and then we can move into the results.
Yeah, so panda reproductive monitoring is kind of an ongoing thing. So it's always been sort of in place. And so really, I just had incorporated adding hormones in to my regular daily setup of monitoring samples. So unfortunately, I went from doing 2 assays a day to about 6 or 7 assays a day. Obviously, when we're adding in new hormones, the androgens hadn't really as much been validated in the sample, so I had to do a lot of validation steps. But I think it was really worthwhile. In the second study, which was looking at utility of androgens in the detection of proestrus and estrus, so we're now looking at a completely different time of the cycle. It really didn't matter if the pandas gave birth or not, which was quite good because I had quite a few that didn't give birth. And normally at the estrus, so monitoring the breeding season, you are just looking at the estrogens and progesterones. This is what's been published for years and years. But we were trying to further optimize how this time is monitored. So we can still use our E1G and our E1S and our P4 kits from Arbor Assays. And for this study, because we didn't have any funding for it, so it was kind of all, we were trying to do things as not as cheaply as we could, but yeah, we didn't have a lot of money to spend on kits. I developed my own in-house testosterone and DHEA assays to use, but I have done some pilot studies, and actually my assays compare really nicely with the Arbor Assays testosterone and DHEAS kits. So you can, as long as you use the same thing across the whole cycle, you can kind of use any method you like for that.
Then you have your experimental setup, you have all of your plates run. Tell us a little bit about what you found.
I was really excited by the results from this study because we were able to show really great uses for androgens in the monitoring of estrus and ovulation. So firstly, the testosterone gave us advanced warning of an upcoming estrus. So traditionally with the estrogen and progesterone, you see a sort of 7 to 14 day increase of estrogens, and that's again varied by panda and by year, and the magnitude of the increase is also quite varied. And what we see is that as estrogens are increasing, the progesterones decrease. But when you look at testosterone, these levels actually decrease 4 days before that of progesterone. So instead of having the 7 to 14 day window, you actually get an 11 to 18 day window. So it doesn't sound like very much, but when you've only got one chance a year, every single day matters when you're trying to plan the logistics. So yeah, most people would be like, that's nothing, but yeah, a few days was great for us. We were quite happy when we found that. And then when we looked at the DHEA, it wasn't so useful at that time, but at the time of ovulation, we saw some really exciting results. So normally for ovulation, you look for a huge decrease in the estrogens, approximately a 50% decrease. But what DHEA did was when estrogen peaked, so before it even decreased at all, DHEA significantly increased. So that was really good. It was showing us giving us potentially sort of 12 to 24 hours in advance that estrogen was going to decrease. And when the fertilization window is only sort of 24 to 72 hours, in this situation, having potentially 12 hours extra is a huge thing, which is particularly important when you're doing an artificial insemination, because generally the chances of that having success are a bit lower. So if you've got some more time to prepare and potentially catch that right window, that kind of hopefully gives you a bit of an advantage over the biology.
Yeah.
So the conclusions from this study were that androgens give a huge advantage and optimization to monitoring that short fertile window. Testosterone is more of a long-term marker, whereas DHEA works on that short range. And one of the really advantageous things about DHEA is that estrogen can be quite fluctuating. Sample to sample and day to day, you do see just natural decreases and increases in the hormones. So sometimes there's a small decrease, but how do you know if that's going to follow on to become the real decrease? Well, DHEA only increases when it is the real peak. So when there are some small increases, which you might think are the decrease, then the DHEA stays flat. But it is only the last one it does increase for, which has been really helpful. We have a few pandas in our bank of samples who really like to fluctuate a lot at those high levels. So DHEA was particularly helpful in providing some clarity for that.
Wonderful. So it sounds like you had some really great new insights, first with the estrogen project, and then building on that with the testosterone and the DHEA to really help narrow down your window and give you a lot more insights into how successful you think that insemination or mating would be for these, very endangered, or at least, critical species that we're looking at with the pandas. As you look back over these studies, are there three things that kind of jump out at you that you would like other people to consider or take in mind as takeaways that they could use in their own labs?
Yeah, so the first thing I would say is that even if there's a method that's been regarded as gold standard, like creatinine has for urinary studies, if there's other potential options, like even things you might just like to try, I would say just try it out. Just give it an investigate. Even a sort of rough preliminary study, just try it. Because us trying the USPG as an alternative to creatinine, even though there was 40 years of research on creatinine, and that's what everyone was doing, that was one of the best things we did, because that led to finding that estrogens were significantly increased in pregnancy. Yeah, if we hadn't done that, I really don't know where my research would have been. So that's definitely a really important thing. Like, just try things out. Like, I mean, if there's good evidence published that says it's not a good idea, that's one thing. But there's so many things that aren't published that are out there that are good options to look at. I say secondly, if you're looking at hormones, definitely think broadly, which is how we came to the androgens. So yeah, most people are like, oh, why would you measure testosterone in a female? But actually testosterone becomes estrogen. It made sense to me when I was looking into it. And the third thing, I would just say, this is quite vague. I would say just the power of a really good collaborator. I think especially when you're working with an endangered or a rare species, when there's so few of them or a few of them in quite spread out locations, that's really challenging to do research. So my collaboration with Jelle from Belgium was completely invaluable, not only in securing those connections to get the samples and make use of the data from other giant pandas across Europe, but also in providing a really good scientific insight and a guidance as a mentor. And then once I'd sort of got a bit more of my place in the community, we were bouncing ideas off each other. Like, you can learn a lot from people working on other species who've maybe got some of the same challenges that you do, or you're working on the same sort of difficult sample type maybe that you've got to figure out. So yeah, you can really like put together information from a lot of different places. So that's a really useful thing.
That's wonderful to hear that you have such a nice resource and network with the ISWE community. And I know there's other similar communities that do a really wonderful job of sharing that knowledge and insight, so we don't all have to reinvent the wheel every time with new challenging species and sample types. Thank you for tuning in to this episode of Research Recap. We hope you enjoyed exploring the exciting research that was done by Kirsten and her colleagues. If you have any questions for Kirsten, please feel free to contact her at the information shown on the screen. If you or someone in your lab has published work using our kits and would like to be featured in a future episode, please be sure to email us at marketing@arborassays.com. Until then, have a great day, and we'll see you in the next Research Recap.